All right, what's up? Time for some more maths. We are going to look at the mechanics section of a step paper today. I've written the question out. My handwriting is subpar, so we're just going to flash the question on the screen for you now. Pachang! Pause it, check it out. But what have we got? A uniform rigid rod is suspended from a fixed point A by light stretch springs A to B and A to C. The springs have different natural lengths, but the ratio of tension to extension is the same. K, was that the modulus of elasticity, I think it is. The rod is not hanging vertically. Show that the ratio of the lengths of the stretch springs is equal to the ratio of their natural lengths. Yeah, is that right? Was the Young's modulus? No, Young's modulus doesn't take into account the natural length, I think. Woo! All right. I'm a mathematician. I don't need to know what the words actually are. Now, so what do we want to show? We want to show basically if they have natural lengths L1 and L2 and extension lengths L1 and L2, we want to show that L2 over L1 is L2 over L1. All right, that's largely what we want to show. So what do we got? Let's put in some forces. We've got mg, we don't know the mass of the rod. Call that point there m. We don't know the mass of the rod, but okay, fine, whatever. There's going to be some tension in that spring. And there's going to be some tension in that spring. So it looks like in terms of my 1s and 2s, we're going to call that spring 1, that spring 2. Let's do some geometry. Call that theta 1, call that theta 2. So we need to set up some equations. Let's see what we can do. Let's take moments about the point M, because then we don't have to worry about the mg. I don't know what m is, but yeah, let's not worry about it. So what's going to ping me clockwise? T1, but I need it to be perpendicular, so it'll be T1 sine theta 1. Okay. And then going the other way round will be T2 sine of theta 2. All right. Now we do know another thing, because this is about springs, their length is important. Normally I'm not too fussed about it, but this is spring 1, so I've already started using that. So the length AB I'm going to call length 1, and the length from A to C I'm going to call L2. And then I can do a little bit of sine rule. That's right. Further maths, step 3, we're using the sine rule. You're never too good for a bit of sine rule. Sine of theta 1 over L2 is sine of theta 2 over L1. Now what we're going to do is basically, what I want is to get rid of the theta, because I don't know what they are. I don't know what they are, so I want them gone. Vamos! Raus! So let's rearrange that for theta 1. That tells me that T1 sine of theta 2 L2 over L1, just rearranging that for sine theta 1, is T2 sine of theta 2. They will disappear. Boop, boop. Which tells me that T1 over L1 is T2 over L2. And I'm just going to call that something. It's a constant. Call it lambda. It's going to make things a little bit tidier in a second. All right. Okay. We could also do L1 over L2, but this is going to do something for me. We want to get this result. So let's have a look. What is L2 over L1? Now, what we haven't used yet is what we know about that ratio of length to the stretch spring. We haven't used that. So that tells me that T2, for example, let's not do that there, let's do that down here. All right, my little working equations are going to be here. I know that T2 is K times L2 minus L1. And in fact, I can rearrange that minus L2 to get the fact that L2 is big L2 minus T2 over K. And I can get that same relationship for the one spring. Do I have enough pens in my hand? Probably not. Let's pop a few of them over here. So L2 is big extension length L2 minus T2 over K. L1 minus T1. Nope, can't do it. Can't do it at that angle. We're going to have to drop. Can you see me? You can see me. That is KL2 minus, and I'm going to deal with that in a second, KL1 minus. Now T2. Well, T2 is lambda L2. If I just rearrange this equation here, that is lambda, T2 is lambda L2. And in the same way, I can get that T1 is lambda L1. And what you might see here, of course, is that I can take out an L2, take out an L1, and the K minus lambdas will cancel out. Q, E, D. Beautiful, beautiful bit of mechanics. Epic. Hope you enjoyed it. Let me know what you think of these little step questions. Useful or not, some of you might have those coming up in the next few weeks. I can't remember what the schedule is. Or am I way beyond. Wrong time. You're getting the offers now. You had your offers. Step is way down the road. But some of you might be starting to think about gearing up to take the step. Hopefully this is useful for you. Let me know what else you want to see. Pop it in the comments. Drop us a like. Drop us a subscribe. Hit the bell. I'm Nick. I hope you enjoyed it. I'll see you next time.